This is Introduction to AutoCAD and Civil 3D, Chapter 3.1, Dimensioning in Civil Design. So, by the end of this class, what you should be able to do is first identify the proper techniques and rules for dimensioning a drawing based on ANSI standards and conventions. You should be able to set up the dimensions in the program of Civil 3D. We're going to be doing this using the dim style command. And then you should be able to demonstrate how to use annotated dimensions and how those could be applied in your civil design. So why do we need dimensions? Now, you would think this is a simple question, but why do we need dimensions? Well, our goal is to communicate complex ideas in such a way that people who don't have an inkling of an engineering background can build what we design. And to do that, we need to identify all the important aspects of that design, where it is, how it's supposed to be built, what it's supposed to be built of, and dimensions are a way of doing that. So dimensions allow a part to be manufactured or an object to be constructed. Dimensions, therefore, should always be in real-world units. So you can't use like hectons or some weird thing like that. It's got to be real-world units. So inches, feet, meters, you do cubits, but it has to be a real unit. Dimensions should be applied in a standard and precise manner. Now, this statement can be a little bit ambiguous. What do we mean by standard and precise manner? Well, we're going to be using certain standards. Most of the rules that I'll be stating will be based off ANSI guidelines. And so we're going to be using those in our design. But as a civil engineering profession, we do some things slightly different. And so as we move on, we'll show those exceptions to kind of those standard rules. So what do you want to do? You want your dimensions to be clear and concise. So you want people to be able to see them, to understand what they are, what they're identifying, and then, but you also want it concise. You don't want to overdo it. So that doesn't mean that you're going to be throwing a bunch of dimensions and notes against the wall and seeing what sticks, because over-dimensioning can cause as many problems as under-dimensioning. So what should be dimensioned? Well, basically any feature in your design. So what are features? Well, if you look at your drawing or your design, basically if you have a corner or an edge, then you need to identify where that corner or edge is located. If you have notches, if you have angles, if there's a curve in your drawing, if there's holes in your drawing, all these things need dimensions. Now, different features will need a different number of dimensions. But like you see in this drawing right here, identifying each of these cuts for the parking lot are going to need certain dimensions. You're also going to want to have overall dimensions or overall heights. And so you want to be able to identify all these in one way or another. Okay? So one of the key things, if you've dimensioned it once, don't repeat it. So if you've dimensioned it in a certain view, don't repeat that dimension in all your various views unless there is a reason for it, because that's when you start becoming unclear. It is the tendency of people that are in the profession that if they see a dimension in one view and then see a dimension in another one, that they're not actually going to be expecting that, because they know you're not supposed to repeat dimensions. So if they see that second one, their thought process is, what are you dimensioning? So you want to put it in the appropriate view and move on. If there are standard features, so let's say like a parking space, and so all your parking spaces are 20 feet deep, 10 feet wide, or 20 feet deep, 9 feet wide. You can dimension one parking space and then identify that it's kind of a standard design by using things like TYP for typical, STD for standard. You could write out a note, all parking lot bays are this dimension unless otherwise noted. Things like that as ways to identify how to do these. So I'm going to be talking about certain things like you shouldn't extend a leader past a certain point, or you want to make sure that you have an extension line on your dimension, or you don't want to cross a dimension line with an extension line. Well, if I set up all these rules, it would be best if you understand what I'm talking about. So if you look at this drawing, what we have here is we've got a nice little kind of standard widget type shape, and so it's 1 inch wide, 2 inches tall. The hole that goes through it is 1¼ inches up, and it's a 0.5 diameter hole. But look at the way that we do the dimensions. So when we're normally talking about curves and all that, we're going to identify the curve using a leader. And so the leader is going to point towards the feature that you're identifying, but it's not going to kind of bracket it. So if you look in this case, it's giving me my dimension for the leader. If you look at the overall width, you have it going from my left to right. It is showing what it's dimensioning. It's dimensioning the overall width, and it's giving me that information. You'll see these little lines right here going up. Those are extension lines. So those are the lines that are actually pointing to the feature you're dimensioning. The dimension line is actually normally going to have the arrow on it. It's going to have the dimension on it and everything else. So extension line is what's pointing to the feature as far as identifying like the beginning and end of what you're dimensioning. And then the arrows and the number are actually showing the dimension. Those are the dimension line. Normally what you try to have is a little gap between your actual design and the extension line. And so you have this small gap. We're going to be using software to do it. So for the most part, we'll leave that kind of up to the software. But this also follows that clear and concise rule, in that I'm trying to make sure that you understand that line isn't something that's part of the design, it's the line is part of the dimension. Also, you will see dimension designs in certain ways that will either be unidirectional or aligned. So unidirectional would be like if I'm holding my sheet of paper, everything is lined up with the bottom edge of my sheet of paper. That'd be unidirectional. You'll see this a lot in ANSI drawings. And so the text is read from left to right, and all your dimensions are kind of set up that way. And then you have aligned dimensions. You will see this a lot with ISO designs, but you'll also see this with civil and architectural designs. And the text is aligned in the direction of the dimension that you're placing. And so this is what you'll see a lot in drawings that we're going to be using. So a couple things that you want to do. This follows the clear and concise rule again. And it also covers the don't repeat a dimension. But it's one of those ways that you don't necessarily realize that you're repeating a dimension. So a couple things right here that you want to notice. First off, if you have a dimension that's longer than the others, it needs to be pulled out away from these. So I don't want my dimension line, remember that's the one that has the arrow, to actually be crossing my extension lines. So I need to pull it up and out of the way. So I don't want to have that happen in my design. The other thing that you want to do is you don't want to repeat a dimension. So in this case, I have a 1 inch, a 1½ inch, and then the overall length is 4 inches. Well, why didn't I actually put a dimension in here? Because I can get that if I subtract out the 1½ and the 1 inch from the 4. So you're not repeating it by showing the one dimension and then the overall. So if you show the overall dimension, you can leave one of the minor feature dimensions out. The other thing is, if you are dimensioning, try to align your dimension lines. So try to keep everything kind of aligned if you can. And so if you look at this, the smaller features right here at 1.5, they're aligned, and then the overall height is up here. The individual features being identified right here are aligned, and then you have the overall length right here. So it just helps in your design. One of the other things you want to try to avoid, and this is actually hard for some of our civil design, but If you can, you'd like to place the dimensions away from the surface of the object. That's easier to do when you're talking about dimensioning out like a part that's going to be in a car. It's a little more difficult with our civil design, but if you can, you want to keep your dimensions off the actual part. Okay? When you're creating the leaders, remember leaders are what we're going to be using for curves and holes and things like that. That leader should actually point, it should touch what you're identifying, but it should point towards the center of that arc. So in this case, you'll notice that it's pointing right towards the center of my circle and all that. So you want to make sure that you do that. And if this is another place where, like what I was talking about is, okay, I gave a diameter here of 1 inch. Well, this one's also 1 inch, but I used a note 2 places to say that that's what this dimension is. So I'm not having to look for the size of this hole because this one says, hey, you got two holes here and they're the diameter 1. So there's a good example of that. If you have something symmetrical, you can measure it. What you normally end up doing is putting a center line, which is this line right here down the middle, and then you'll put your overall dimension set up like that. So symmetry is a way to draw something out like that. And then coming down to the clear and concise, sometimes trying to fit your arrows and fit your dimensions and all that in the same part can be difficult. And so it's okay to adjust your dimensions accordingly. And so in this case, I don't have enough room to put everything here, so there's a gap between these 2 points, but I have the number right here. In this, I've kind of forced it in the middle, but I don't have the arrows, but you still have the extension lines to understand that dimension. In this, I can fit the numbers in, but I can't fit the arrows. That's okay, they're outside, and then we have our standard. So let's go ahead and look at a basic design and how I want to dimension this, okay? So before we get started, what I'm commonly going to need to dimension as far as the feature is concerned is something in the X and Y direction. Now, if you're dealing with something that is not planar, you might also need to dimension in the Z direction. And we're going to give Z dimensions a lot in civil design, but a lot of times, a lot of our site plans and all are kind of planar when we're doing those parts of the design. And so we give something in kind of an X and Y or northing and easting or something like that as far as dimensions go. We'll identify or break it down like that. But the Z component will either be listed out as an elevation or something to that effect. So I'm actually in Civil 3D right now just to kind of show you this design. And so I've got kind of this basic design, and I'll go into the details of how to dimension, but it's more what should be a dimension is what I want to talk about here. So if you look at it, I have this kind of widget shape. And we'll assume it's planar because I don't have any other views to tell me otherwise. So what I want to do is I want to kind of dimension this out. So if you look, one of the first things that you normally want to do is you want to dimension the overall dimensions. So how big are the overall dimensions? How tall it is, how wide it is, that sort of thing. And so that's one of the things I wanted to mention. Then I wanted to mention the features. Well, if you look at this, I have a couple features. If you look right here, I have an edge that drops down here, and then if you look over here, I have an edge that comes over here. So I want to identify those. And then if we look in the vertical direction, I have my start point here. I've got this point right here. I've got the end of my angle right here, and I've got the overall of my height right here. So all these I want to dimension. So let's go ahead. I'm going to real quickly kind of set this up. And so, like I said, the first thing I want to do is dimension the overall dimensions. And so I want to dimension how high that is, and then I want to dimension how wide that is. So I identify those two dimensions. Then I can start looking at each of these features. Well, it's important. I've got this edge, I've got this edge, and then this comes over here. So let's dimension. So I'll dimension here to here. So I know that that's 1 inch. And then I'll dimension from here to here, and I know that that's 1.5 inches. And then I dimension from here to here, and I know that that is 1.5 inches as well. But a couple things you'll notice. First off, I have this little cluster right here going on. And so normally I might want to change it, something like that. So now it's still clear. We can see all the things. We don't have anything crossing itself right here. So I don't have a cross here or here, here. This extension line comes up, but there's no dimension lines that are crossing each other. The other thing, remember I said you don't have to give an overall dimension of or you have to give an overall dimension, but you don't have to give all the in-between dimensions in there, because you can figure that out if you work it out backwards from the overall dimension. And so I can get rid of one of these featured dimensions. Now here's the interesting thing. Which one do you get rid of? Well, that's going to depend a lot on your design. If there's certain things that it's very important that that dimension is correct, you want it dimensioned. So if it's really important that this is exactly 1.5 units wide, then I'll probably leave this dimension. If it's really important that this one is 1 inch wide, 1 unit wide, I'll leave that dimension. What that basically is saying is, okay, this gap isn't as important as this needing to be one unit and this needing to be 1.5 units. So I could get rid of this one overall. You learn that as you work more with your designs. In this case, I don't really know any of them. I'm going to go ahead and get rid of this one in the middle, and I'll just hit delete. And so now we have those set up. All right, so let's go with the vertical. So I'm going to come over, and in the Y direction, basically, I want to identify, we've already identified the overall height, so I want this, which is 1 unit, and then I want this, which is 2 units. And then once again, I don't have to do the overall height because it's over here. I already have that in this view. Now, if you want everything consolidated, remember, and that might be one of the things you want, especially when you're trying to be clear and concise, what you may want to do is go ahead and dimension that overall height over here. So I end up with these dimensions as how my drawing is going to be set up. So if you look, this feature, that ledge right there, I know is 3 feet up, and I know it's 3 units up and 1 unit wide. Right over here, I know that this little shelf right here is 1 unit up. I also know that it starts 1 unit from the left and will continue over. Now in this case, I have this dimension right here is 1.5 units. That's where this edge is going to be from the far edge over here. And so I have everything dimension that I need in this design. And so this is kind of an example of how you would design out a part. Now this is pretty standard ANSI style. We're going to be talking about civil styles in a little bit, but this is how you would design out kind of your general design and dimension it if you're going for just any type of engineering design drawing. So in conclusion, dimensions should be done using a standard format. They should be clear and concise, and most features in a design drawing need to be dimensioned in the X and the Y direction. Now that we have the general idea of what our dimensions should look like, we can look at how to do it in a software like Civil 3D. So that's what we'll be doing next in the next video.